Thank you so much for having me. Okay, I'm going to jump into highlighting some of the recent improvements that we have been making within the earthaccess library to further streamline the existing integrations with virtualizarr, and definitely presenting on behalf of the broader earthaccess contributor and maintainer community. So for those of you who are less familiar with earthaccess, just a quick slide on kind of who we are. This is a highly active open source Python library that was created and continues to be enabled through the NASA OpenScapes mentor community, as well as with broad community contributions, not only within NASA data centers, but across other NASA partners, private industry, and really the broader earth science data user community as well. And I love this image highlighting kind of where earthaccess sits in this sort of translation and workflow from archived environmental data into impactful science. So we wanted to highlight a recent release, version 0.17. This was released last month, and this is a slide that I'm presenting from Luis Lopez, kind of calling it the Cloud Native Access Patterns Edition. So, I think we're all quite familiar with some of the sort of consequences and downsides and issues that scientists and researchers face with a more traditional download file by file access workflow and paradigm. But even in the cloud-based approach and sort of, what we have been supporting within NASA Earth data, we are towards the finish line of moving all data into the commercial cloud, into AWS, but still sort of sitting in this space of bad user patterns where we are just kind of lifting and shifting data that's in traditional non-optimized archival formats, where we're negating those benefits of cloud storage, still sort of having to work in this file by file based approach, even though we have some better uptimes and scalability. Where earthaccess has been really focused is, in collaboration with other work going on in the virtual data store technology space, how can we sort of leverage those technologies to integrate that into, again, a streamlined workflow going from search into a more cloud native access pattern, even when sort of utilizing and working with those traditional formats. So this is the space, again, that we've been actively involved in. With this new version, what we have been doing, I'll just flash this quickly and then move over to the demo. But I think the main update here is that the function that we've now integrated into earthaccess makes this virtualization much, much simpler for end users. So we can leverage existing file by file based chunk manifests from DMR++ that are already archived in NASA Earth data, and just in a single streamlined function, translate those into ZAR metadata to open into a single X-ray data set. But I will actually go ahead and demo that workflow now. So this is just a toy example that is included in the earthaccess documentation. We're looking at a data set from the Tempo mission. This is a fairly new mission. This is a level 3 data set that highlights nitrogen dioxide along a tropospheric and stratospheric column. So we're just looking at 8 files over a week plus a day. And then I'll run these 2 cells that is highlighting that simple step 2 to virtualize those files into a unified data cube. So on the back end, there's 4 libraries at work: earthaccess, virtualizarr, Dask, and Xarray. And in this example, what we're doing here is, again, leveraging these single file chunk manifests. We're parsing and aggregating them into a single manifest file. But there's gotchas here. Like, this only works really for homogeneous, CF compliant, consistently gridded data files. We know you need that deep understanding of data structure. So in this particular case, there's many options that we have to know about and sort of set as keyword arguments into this virtualized function. But I'll highlight one of them. We're just going to concatenate along the time dimension. And then we're doing this kind of 3 times because of the grouped structure of these netcdf files. So that's why this is happening 3 times, but we're just in that simple call, virtualize those results, passing those options along. And then this is actually accessing outside of the cloud. It's about 3 times faster in the cloud, but in about 17 seconds, we have that single data set. And then I'll just run these quickly. We could do then simple fun things with that single data set, like getting a temporal mean and then mapping them. um, along a overt area of interest. And then really quick, I just wanted to highlight some of the things coming soon, which I think is huge. This is a lot of work that Luis Lopez has been working on with a single open virtual function. And so this is two lines where you can search for an entire collection, again, within NASA Earth data, and then just using open virtual, you can open that entire collection, in this case, taking 22 seconds. Or you can pass along with, again, single open virtual function and a known chunk manifest across an entire collection, in this case, a SMAP data set. Get if you know that URL. This is in Parquet format. And in less than a second, we're opening the entire time series that reflects 33 terabytes of data. Again, that work is coming soon.